Alright, welcome back everybody. Today we are talking about optics, lights, lenses, mirrors, everything to visually see something. Alright, let's get started. So before we start, we're going to start with the very basic light. What is light? Just generally speaking, how does it all work? How to understand light a little bit better. Alright, so here we go. Light and sound are two ways to receive information. I know we don't really think about receiving information from light or sound, but when we talk, we give out information, and when we listen, we can hear information. That's sound. And light, if you're waving your hand or you're showing excitement, that's a way of receiving information, is by observing what's going on. And that's the most basic way. There's so many other ways that we can receive information from light and sound, but just talking about that. Light provides a great variety of information than sound. The eye can detect small changes in size, position, brightness, and color. Light travels much faster than sound. Light travels at about 300 million meters per second. I know we don't really think as light traveling, but yes, light goes very fast. And I think this is most obvious with a lightning bolt. So like when we see like lightning striking, we see the lightning and we see it pretty quickly because it's going so fast. And then a few seconds later, depending on how far you get, we hear a boom, the thunder. So the reason why we see the lightning first is because the light is traveling really fast, while sound takes a while to catch up. Okay, so this means that when I move my hand, the people in front of the classroom are seeing that movement faster than the people in the back of the classroom. So we have people in the front over here, and then maybe people in the back over there. What happens is, if you're moving your hand over here, you think that this person and this person sees the hand moving at the same exact time. You think that visual happens instantaneously. However, that's not exactly true. When this hand is being moved, what happens is it takes a while for that motion to be received by the other people. So this person here is going to see that hand being moved before this person in the back. It's only going to be slightly before, because light travels so fast, but this person will be seeing it before this person in the back over here because they are closer. Okay, so a little bit of how light works. Light travels in a straight line, which are represented by rays. Rays are an idealized way of understanding how light moves from a source or how it reflects off objects. We'll talk about this soon. Objects are visible because light reflects off them in all directions. You can see an object when the rays that reflected from it reach your eyes. Okay, so let's kind of back up a little bit. So if a room, let's say we have a book, we have this book here. But if the room is pitch black, there's no light or anything on there, you can't see this book because it's pitch black. So we need to have light be able to show the book. So what's going to happen is a ray of light is going to come on and hit this book. And once it hits the book, it's going to bounce off in all directions. And then if somebody is looking at it, when it bounces off, you're going to notice, oh, there's a book there. Okay, so objects are visible because light reflects off of them in all directions. You can see an object when rays that reflect from it reach your eye. Okay, imagine a book on a table. Light from a lamp or window reflects off the book in all directions. Some of these rays reach your eyes, allowing you to see the book. If an object blocks the light, you won't be able to see the book from that angle. All right. Moving on, let's do some problems. You are playing baseball and playing center field, position 8. Your friend is the shortstop, position 6. If the opponent hits the ball, who will notice the ball being hit first? Okay, so the person hopefully know a little bit of baseball, they hit the ball over here. So if the ball gets hit over here, that means it's going to take some time. Light travels very fast, but it's going to take a little bit of time for that information to come to person at position 6, and the person at position 8. But since the person at position 6 is closer to where the ball was hit, they will notice that the ball gets hit faster than the person at ball number 8. So the person at position 6, which is your friend. Okay? I hope that makes sense. It's starting to see like visuals with your eyes. That information takes time to get to you. And even though in these kind of short distances it's a very similar amount of time, it's still, the closer you are, the faster you're going to get that information coming to you. In this case, the ball being hit. All right, moving on. An astronomer is looking at the sun, which is 100 million or 100 billion meters away. While looking at the sun, an asteroid crashes into the sun. How long will it take before the astronomer sees with her own eyes that this crash happened? Speed of light is 300 million meters per second. Okay, so this astronaut crashes into this sun, and that information is going to take a while for this astronomer to see. So we're trying to figure that out. So we know that the distance this visual is going to be happening is happening from 150 billion meters away. We know that information is going to be traveling at the speed of light, which is 300 million meters per second. And we want to know how much time this takes. Okay, so we're just using that formula we've always seen before. Speed equals distance over time. And we're doing a little bit of algebra, knowing that time is equal to distance divided by speed. So distance is 150 billion divided by the speed, 300 million. And then let's see what we get. Let me put that in my calculator. 1, 2, 3. 1, 2, 3. Divided by 3. 1, 2, 3. 1, 2, 3. 500 seconds. Or 30 minutes. Or 8.33 minutes. Okay. All right. So that's pretty much it. That's pretty much the basics of light and how it works. Of course, there's a lot more to it, but the basics of what we need to know for this chapter. All right. So we're going to talk about reflection and mirrors. So I hope to see you with that. Thanks for watching, everyone.